The EM-8 Greyhound armored car represented one of the most successful light reconnaissance vehicles ever deployed by the United States Army during World War II. Fast, nimble, and armed with a 37mm main gun, this six-wheeled warrior served on every major front from the hedgerows of Normandy to the Pacific Islands. Between 1943 and 1945, Ford Motor Company's massive production facilities churned out over 8,000 of these vehicles, each one a testament to American industrial might and engineering innovation. But the story of the M8 Greyhound begins long before the first rivet was driven or the first armor plate was welded. It begins deep in the earth, in the mines of Minnesota's Iron Range, the steel mills of Pennsylvania, and the rubber plantations of South America. The Mesabi Range in northern Minnesota had been supplying America with iron ore since the 1890s, and by 1943, the war had pushed these operations into overdrive. Giant steam shovels, some weighing over 300 tons, bit into the rust-red earth 24 hours a day. Each scoop could lift 15 tons of ore-bearing rock, and the machines worked in a carefully choreographed dance, loading hopper cars that snaked through the open pits like mechanical serpents. The ore itself was taconite, a hard, low-grade iron formation that required more processing than the rich hematite deposits that had been largely exhausted by this point in history. Underground, where some mining still occurred, men worked in shifts around the clock, drilling blast holes with pneumatic equipment that filled the tunnels with deafening noise and choking dust. The ore they extracted contained only about 30% iron, meaning vast quantities had to be moved to produce the steel needed for a single armored vehicle. From the mines, the ore traveled by rail to the port of Duluth, where massive loading facilities transferred it onto lake freighters. These ships, some stretching over 600 feet in length, carried as much as 14,000 tons of ore across Lake Superior to steel mills in Gary, Indiana, and Pittsburgh, Pennsylvania. The voyage took 3 days in good weather, but storms on the Great Lakes could be ferocious, and more than one ore boat went to the bottom during the war years, taking its cargo of future tanks and armored cars with it. At the receiving docks, giant Hewlett unloaders, towering mechanical arms with clamshell buckets, that grabbed 15 tons of ore at a time and swung it onto conveyor belts that carried it to the stockpiles. The scale of these operations was staggering. A single steel mill might process 50,000 tons of ore in a week, and much of that would eventually become armor plate. The transformation of iron ore into steel, suitable for armor plate, was an alchemical process that combined extreme heat, precise chemistry, and decades of metallurgical knowledge. At the blast furnaces, the ore was mixed with coke, a purified form of coal that had been baked in enormous ovens until it was almost pure carbon, and limestone, which served as a flux to remove impurities. These ingredients were loaded into the top of blast furnaces that stood as tall as 10-story buildings. Inside these towering structures, on temperatures reached 2,500 degrees Fahrenheit, as preheated air, or sometimes pure oxygen, was forced through the mixture from below. The limestone combined with impurities to form slag, which floated to the top and was drawn off, while the iron, now molten and called pig iron, was tapped from the bottom in glowing orange streams that filled vast ladles. But pig iron was too brittle and contained too much carbon to serve as armor plate. It had to be converted into steel, and for the armor of the M8 Greyhound, that meant steel with specific properties of hardness and ductility. The pig iron was transferred to either open hearth furnaces or, increasingly by 1943, to electric arc furnaces that could produce steel of exceptional purity. In the open hearth process, the pig iron was melted again, along with scrap steel and carefully measured amounts of other metals like manganese, chromium, and nickel. These alloying elements would give the final steel its ability to resist penetration, while remaining tough enough not to shatter under impact. Furnace operators, their faces protected by tinted goggles and leather hoods, used long tools to take samples of the molten steel, which were quickly cooled and then tested for carbon content and other properties. When the chemistry was perfect, the steel was poured into massive ingot molds, each one creating a block of steel that weighed several tons and glowed white-hot. These ingots were then transported to rolling mills while still hot, because reheating them would waste precious fuel and time. The rolling process was where raw steel became armor plate. The ingots passed back and forth through enormous rollers, each pass compressing the steel and lengthening it, refining its grain structure and increasing its strength. For homogeneous armor plate, which was what the M8 Greyhound used, the steel was rolled to a thickness that would eventually be either 5/8 of an inch for the hull front and turret, or 3/8 of an inch for the sides and rear. The rollers exerted thousands of pounds of pressure per square inch, and the mills filled with a thunderous roar as the red-hot plates passed through again and again. Cooling was carefully controlled, because rapid cooling could create internal stresses that would make the armor brittle, while too slow cooling could leave it soft. The plates were often quenched in oil baths, and then tempered in ovens to achieve exactly the right balance of hardness and toughness. Meanwhile, rubber for the M8's 6 large tires was arriving from plantations in Brazil and Liberia. Natural rubber came from Hevea brasiliensis trees, and harvesting it was labor-intensive work. Tappers would make diagonal cuts in the bark, allowing the milky latex sap to flow into collection cups. Each tree could only be tapped every other day, and a skilled tapper might work several hundred trees in a single morning shift. The raw latex was collected and mixed with formic acid to coagulate it into solid sheets, which were then smoked over wood fires to preserve them and prevent bacterial growth. These sheets, brown and pungent with the smell of smoke, were packed into wooden crates and shipped by coastal freighter to American ports. In the United States, the rubber arrived at processing plants where it was mixed with sulfur and other chemicals in a process called vulcanization, which transformed the soft, sticky natural rubber into a durable, elastic material that could withstand the punishment of military use. The Ford Motor Company's facility in St. Paul, Minnesota, where the M8 Greyhound was manufactured, had been converted from truck production to military vehicle production in late 1942. The plant covered millions of square feet and employed over 20,000 workers, many of them women who had taken the places of men now serving overseas. The transformation of raw materials into finished armored cars began in the fabrication shops, where the armor plates arrived by rail. For these plates had been cut to rough dimensions at the steel mills, but now they needed to be shaped, drilled, and formed into the specific components of the M8's hull and turret. Massive hydraulic presses, some capable of exerting 3,000 tons of force, bent the plates into curves. The front glacis plate, which sloped at a 30-degree angle to deflect incoming fire, required particularly careful forming to avoid creating weak spots or cracks in the armor. Welding the hull together was skilled work that combined craftsmanship with industrial precision. The M8's hull was assembled upside down on massive steel jigs that held each plate in exact alignment. Arc welders, their faces hidden behind dark-tinted helmets, ran continuous beads along every joint. The welding had to be perfect, because a weak weld could split under the stress of combat, or even just rough terrain. Each welder worked with electrodes specifically formulated for armor steel, and the intense white-blue light of the arc could be seen dancing along the assembly line like captured lightning. The smell of hot metal and welding flux hung heavy in the air, and the floor was littered with the stubs of spent electrodes. Quality inspectors followed behind the welders, using magnetic particle testing to check for cracks or inclusions. Any defects meant cutting out the bad section and rewelding it, a time-consuming process that could delay production. The turret was manufactured in a separate facility within the same plant. It was a more complex piece than the hull, with a rotating mount for the 37mm M6 gun and a coaxial 30 caliber M1919 machine gun. The turret ring, the circular bearing assembly that allowed the turret to traverse, was precision machined from a single forging of high-strength steel. This component had to be manufactured to tolerances of just a few thousandths of an inch, because any wobble or binding would make it impossible for the gunner to track targets smoothly. The machining was done on vertical boring mills, where the turret ring was mounted on a slowly rotating table while cutting tools shaved away excess metal with mathematical precision. Coolant flooded the work, washing away metal chips and keeping the cutting edges from overheating. The M6 gun itself arrived from another supplier, having been manufactured at facilities that specialized in artillery production. These guns were rifled, with spiral grooves cut into the barrel that would spin the projectile and give it stability in flight. The barrel was made from a special gun steel that could withstand the enormous pressures generated when the propellant charge ignited, sometimes reaching 40,000 pounds per square inch. The breech mechanism, which opened and closed to load rounds and sealed the rear of the barrel during firing, was an intricate assembly of levers, springs, and precisely machined parts. Assembling and testing each gun was exacting work, and every completed weapon was proof-fired before being approved for installation in a vehicle. The chassis of the M8 Greyhound was built around a modified six-wheel drive truck design. The frame rails were heavy channel sections of high-strength steel, riveted and bolted together to form a rigid ladder that would support the weight of the armor and running gear. The suspension system used leaf springs at each wheel position, massive multi-layered assemblies of spring steel that were clamped together and mounted to the frame with heavy brackets. These springs had to be heat-treated to give them the right combination of flexibility and resistance to fatigue, because they would be subject to constant flexing over rough terrain. The wheels themselves were equipped with run-flat inserts, because a vehicle with 6 wheels could continue operating even if 1 or 2 tires were shot out or punctured. Power came from a Hercules JXD inline 6-cylinder gasoline engine, a rugged design that produced 110 horsepower. The engine blocks were cast iron, poured in sand molds at foundries that ran 3 shifts a day. After cooling, each casting was machined to precise dimensions, with cylinder bores honed to a mirror finish and bearing surfaces ground to tolerances measured in 10,000ths of an inch. The crankshaft was forged steel, hardened and balanced to reduce vibration. Assembly of each engine followed a carefully sequenced process, with pistons, connecting rods, and bearings installed by workers who had become specialists in their particular step. Once assembled, each engine was mounted on a test stand, where it was run for several hours under load, with technicians monitoring oil pressure, coolant temperature, and power output. The transmission was a 4-speed manual unit, with heavy-duty synchronizers to allow smooth shifting, even under combat stress. The transfer case split power between the front and rear axles, and both could be locked together for maximum traction in mud or sand. The axles themselves were massive assemblies, with differential gears cut and lapped to minimize backlash and ensure smooth power delivery. The final drive ratio was chosen to give the M8 a top speed of 55 miles per hour on roads, making it one of the fastest armored vehicles in the American arsenal. On the assembly line, the hull and chassis came together in a carefully orchestrated sequence. Overhead, cranes lowered the armored hull onto the chassis, and workers guided it into position with long pry bars before bolting it securely in place. The engine was installed next, lifted by a specialized hoist, and maneuvered into the engine compartment at the rear of the hull. And mechanics bolted it to its mounts, and then began the tedious process of connecting all the mechanical and electrical systems. Fuel lines had to be routed and secured, the exhaust system installed, cooling hoses connected, and the drive shaft aligned and bolted to the transmission. Every bolt was torqued to specification using calibrated wrenches, and every connection was checked and double-checked. The electrical system was a complex network of wiring that powered everything from the starter motor to the turret traverse motor to the radio. The M8 used a 24-volt system, which was more reliable than 12 volts for starting the big engine and powering the various electrical loads. Workers would spend hours routing wires through the hull, securing them with metal clips to prevent chafing, and connecting them to junction boxes and switches. The radio, usually an SCR-508 or SCR-528, was mounted in a shock-absorbing rack and connected to both power and antenna. Testing the electrical system meant checking every circuit with meters, ensuring that power was reaching every component and that there were no shorts or grounds that could cause failures or fires. The turret installation was one of the final major steps. The completed turret, with gun, machine gun, and all internal equipment already installed, was lifted by crane and carefully lowered onto the turret ring. The fit had to be perfect, and mechanics would spend time adjusting shims and checking that the turret could rotate smoothly through its full 360 degrees of traverse. The gunner's periscope was installed, thumb along with the gun sights and the elevation mechanism. Inside the turret, ammunition racks were fitted to hold the 37mm rounds and belts of .30 caliber ammunition for the machine gun. Vision devices and hatches were critical for crew survivability. The driver and commander each had armored glass vision blocks that could be covered with heavy steel shutters if the vehicle came under fire. The hatches were thick armor plates hinged to the hull and turret, and each one had to fit tightly enough to keep out water and dust, but still be easy enough to open from inside. Seals were installed around each hatch, and locks and latches were carefully adjusted. Painting was done in a separate facility, where each vehicle was thoroughly cleaned and then coated with a primer that would prevent rust. The final coat was olive drab, the standard color for American military vehicles in Europe. The paint was applied with spray guns, and workers wore respirators to protect themselves from the toxic fumes. Once painted, each vehicle received its markings, including the white star that identified it as American and tactical numbers that indicated its unit assignment. These were often applied with stencils, though some markings were hand-painted by artists who had become adept at lettering. Testing was rigorous and comprehensive. Each completed M8 was driven off the assembly line and onto a test track, where it was subjected to a series of trials designed to verify every system. The first test was simply to drive the vehicle through a series of maneuvers, checking that the transmission shifted smoothly, the brakes worked properly, and the steering responded correctly. The turret was traversed through its full range, while the gun was elevated and depressed, ensuring that nothing bound or interfered with the mechanism. The gun was not fired at the factory, but the recoil mechanism was cycled and checked for proper operation. Road testing included high-speed runs to verify that the M8 could reach its design speed and handle properly at those velocities. Drivers would take the vehicles through obstacle courses that included steep grades, water crossings, and rough terrain that simulated combat conditions. Any vehicle that failed to perform was immediately pulled from the line and sent back for repairs or adjustments. This quality control was essential because a failure in combat could cost lives. Once a vehicle passed all tests, it was prepared for shipment. Fluids were checked and topped off. Some batteries were installed and charged, and tools and spare parts were loaded into the storage compartments. Each M8 was then driven or loaded onto rail cars for transport to a military depot. From there, vehicles might go directly to units training in the United States, or they might be crated and loaded onto ships bound for Europe or the Pacific. The journey from factory to front line could take months, with vehicles sitting in depots, bouncing across the Atlantic in convoy, and then being driven through the rear areas to finally reach combat units. The logistical challenges of supporting M8 production were immense. The factory required a constant supply of not just armor plate and engines, but thousands of smaller components. Fasteners by the millions, gaskets and seals by the thousands, electrical components, rubber parts, glass, and countless other items all had to arrive on schedule or the assembly line would grind to a halt. Ford employed dozens of expediters whose sole job was to track shipments and solve problems before they caused delays. During the war, American industry became expert at this kind of coordination, with raw materials flowing from mines and farms through processors and manufacturers to final assembly plants in a carefully synchronized dance of production. The human cost of this production was significant. Workers on the assembly line put in long shifts, often 6 days a week. Injuries were common, from burns suffered by welders to crushed fingers and broken bones from the heavy equipment and components. The noise was relentless, the air often thick with fumes and dust, and the pressure to meet production quotas was intense. Women workers, in particular, faced skepticism and sometimes outright hostility from male colleagues who questioned whether they belonged in such demanding industrial roles. Yet they proved themselves capable, and many became expert welders, machine operators, and inspectors whose skill was equal to that of any man. By the time the last M8 rolled off the line in April 1945, the Ford plant had produced a total of 8,523 vehicles. These armored cars served with distinction in the reconnaissance squadrons of armored divisions and cavalry groups across Europe. They were fast enough to scout ahead of the main force, well armed enough to fight through light resistance, and tough enough to survive the rigors of combat. The M8's six-wheel drive gave it mobility that few other vehicles could match. Airborne and crews appreciated its reliability and ease of maintenance. In the Pacific, M80IS served in the Philippines and Okinawa, proving equally capable in jungle and urban combat. The legacy of the M8 Greyhound extends beyond its service in World War II. The vehicle represented a high point in American armored car design, combining speed, firepower, and protection in a package that was both practical and effective. The manufacturing techniques developed to produce it, from the welding of armor plate to the assembly line integration of complex mechanical and electrical systems, would influence vehicle production for decades to come. The industrial mobilization that made the M8 possible demonstrated the power of American manufacturing, the skill of American workers, and the effectiveness of coordinated logistics on a continental scale. In every M8 that reached the front lines was the product of thousands of hours of labor. From the miners who extracted iron ore to the assembly workers who bolted the final components into place, and each one stood as a testament to what American industry could achieve when pushed to its limits by the demands of war.